So welcome back to pre-algebra, and we are in day 2 for the first section of the book. Section 1, chapter 1. So this is still on page 5. It all begins on page 5, but now we're into the second part. So it's probably something more along the lines of page 7. Okay? So variable. We mentioned variables yesterday. Right now in your concept book, write down variable, underline it, and put the shortest definition you can think of for variable under your word. Next. He says a letter replacing a number. That's really short. Has anyone got a shorter definition? Rishi. A letter to represent an unknown. Actually, that's a really good textbook. Did you get that out of the textbook? No? You did that all on your own? That's awesome. Because that's really close to the definition I have. Josh?
Letters for unknown numbers.
Letters for an unknown number. That's right. So anything like that is perfect. Let's see what we have here from the book. It's very much like Rishi's. Letter that represents an unknown number. So we could say the letter N is a variable. It could represent any number. Somebody could tell you that N equals 2, and you would use that then, right? So a letter that represents an unknown number. When you're down in first grade, do they use variables in math? No, we actually see them using what instead of a variable? When they're learning little fact families, what did they use instead of a variable? In here, we might say 1 plus x equals 3. But in first grade, what would you see? Good, a blank line or a box or an open circle, right? And when they get into looking at data, they don't use variables, they use trees and sunshines and fruit or whatever. People with half people, you know, remember that? Little pictures. And so probably they are still really working on reading anyway, so imagine how confused they would be to throw letters into their math. They wouldn't know what was what, okay? You guys are ready for variables. And when we use variables, we're actually using algebraic expressions, right? So an algebraic expression is a variable expression. It may have numbers, although it may just have variables. X plus y. There's an algebraic expression. Or I could say x plus 2. Is that still an algebraic expression?
Yeah.
Yes. It may have operations. My example, x plus 2 has one operation. We could get more fancy than that. It could just be a variable, z. That's an algebraic expression all alone. It is a variable, okay? We're going to evaluate algebraic expressions today. Okay? So yesterday we were just given numeric expressions and we used our order of operations. Today we're stepping it up a notch. We are being given algebraic expressions, and then they're going to just give you a value for the variable. So this first expression is 5y minus 10. And then they're telling you y is going to equal 4. So what are we going to do with this information here?
So you bring it down and then you do 5 times, what do I do with that?
How about parentheses?
Parentheses times 4 minus 10.
And there it is, yay. I say we plug it in, like a Glade air refresher. You plug it in. Actually, the math term for putting the 4 in for y is a common word that we use in sports all the time. So if you ever played soccer or basketball and they moved a person on the field or off, what do we call that? Substitution. And that's the math term for this. We substitute 4 for y in the expression. And now we're right back to where we were yesterday. We have a numeric expression, and we have to remember our order of operations, right? Solve it in the correct order, or simplify it in the correct order. We're not solving. Solving is what we do when there's an unknown. But look, there's no unknown. So we're simplifying this to the simplest form. Okay, so together 5 times 4 is?
20.
So 20 minus 10 is?
10.
And there you go. We have found the value. Evaluate. Found the value. Okay, who would like to come up and show us this one? We've got 2 variables. And keep your hand up if you haven't come. Okay, so Matthew has substituted the correct values for the variables. And now he's thinking of his order of operations and thus. He says 6 squared is 36. That's true. And 3 cubed, he says, is 27. Now, if you want to work anything out, you come over to the side and work it out somewhere so that the space beneath your expression is still clean. Put the stuff there, right? So on your assignment, you use the same process where you use the space over on the right for scratch paper and keep the area where your expression is flowing down, you keep it nice and clean. Okay? And now he's doing the final step, multiplication. And thumbs up if you agree. 126. Excellent.
Good job.
Beautiful work. Good. Okay, we have just a few more. Who would like to do these? Okay, so if you are not live in class, then pause the video and then we'll bring it back. Come back when you have completed these and check your work. Okay, there you go. Beautiful work by Adrian there. And now we have 2 additional examples. And once again, if you are at home, pause, come back and check your work. And there you go. Beautiful work. Substituting the known values and then evaluating. Okay. And there you go.